Hey everyone, let's start with question number 11, Digital Electronics, asked in GATE examination 2025 instrumentation branch. The clock frequency of the digital circuit shown in the figure is 12 MHz. The frequency of the output F corresponding to control 0s and control 1 respectively are. Let's start analyzing the circuit. There are two flip-flops A and B. We will write this A and B so that you can better understand. This is, let's say this is A D flip-flop and this is B. Let's start writing its solution. If you carefully see that what is the expression for TA, which is nothing but QA plus, which is nothing but, you will see this signals is coming from this side, which is nothing but QB bar, which we write here as QB bar. And now considering first that control is 0. First we will write for the expression when control signal is 0. If this is 0 and dA is equals to QA plus and we write next for dB is equals to QB plus. So first you see that dA is equals to QA plus, which is nothing but QB complement. You got your first expression. Now similarly dB is equals to QB plus. So what is dB? dB is here. What comes here is control 0 and which is QA. So here we got that QA. QA R with 0 comes out to be QA, and QA with AND, which is in QB complement, here comes out to be QA dot QB complement. So you got your second expression. I hope this is clear. Now we will write we can draw the clock for the explanation of the frequency. Always draw the clock signals. Start drawing the clock signal, and you can see that these clock are synchronized and are positive edge triggered. Let's take two more clock pulses. We should always draw these clock pulses for your better understanding, and no matter what time it takes, but you will get your answer correct. This is your clock signal. Now you have to see the clock signals are positive as triggered. This I already said. Now look at the QA and QB signals, what they are going to be. Let's assume that initially they are both at 0, 0. What you want to find this F frequency. So whatever will be the frequency of QB will be same as QB complement, which is nothing but F. So once you find the frequency of QB, it is complement of QB, which comes out to give your frequency of F output. If you find frequency of QB, you will get the frequency of QB complement. in control signal 0 as well as in control signal 1. That doesn't changes because f is stick at this point, which gives you QB complement, which is the complement of QB. And once you get the frequency of QB, you will get the frequency of QB complement, because nothing will change. These signals both are complement of each other. That's why I am writing the signal QA and QB. Now write the next state of QA. QA is QB complement. Next state of QA is QB complement, which comes out to be 1. Okay. And what is the next state of QB? Next state of QB is QA dot QB complement. QA is 0 and QB complement will be 1. So 1 0, sorry, that again comes out to be 0. Now complement of this is again 1, and this is QA QB complement. QA is 1, QB complement becomes also 1, and operation, then it comes out to be 1. So we'll get 1. Again now complement of this comes out to be 0. Now again I am highlighting with different pen. This is 1 and this complement of this 1 is 0. So AND operation of both is 0. Copy this. I will say complement of this comes out to be 1, and I take this as 0, and complement of 0 is 1. Both operation and operation, again 0. Now again this is your complement. I am following the same steps, and again now you have to look that QA and complement of QB is going to be 1. So 1 and 1 be 1. Now you will see that the sequence again start repeating. So if you have a time period T and frequency f of clock, so its time period, you can see that T dash becomes 3T, or you can say frequency becomes f divided by 3 for QB. Once you get QB, what I was saying, that once you get QB, you will get QB complement. I am drawing the signal of QB complement. So nothing will changes with frequency. This is 1 1 0 1 1 0. So time period of frequency remains the same. This is for QB complement. So when control signal is your 0, the frequency becomes 12 divided by 3, 4 megahertz. What will change when your control signal becomes? Now your control signal, although you can find that the 4 megahertz is only one of the options, you will get option A would be correct, but let's find how 6 megahertz comes for control signal 1. Now if your control signal is 1, let's again write the expression for control signal 1. Let's see the diagram. When your control signal is 1, what would happen? When your control signal is 1, what would happen? This OR operation doesn't matter what will be the input here. It will always give you output as 1 here. And AND operation with 1 only depends upon the input what is on the other hand. On the next hand, you have the input is QB complement. So output of here is QB complement, and input to A is QB complement. So DA, your DA or we can say QA plus is the same as previous, that is QB complement. This is your first expression. Now DB is changes to, this is also becomes QB complement. You can see from this DB comes out to be QB complement. Now we got both the expression. We again draw the signals. It is very much preferred to draw these signals again and again for your better practice. These are all positive edge triggered. Now again we will write QA and QB. Initially both are at 0, 0. Now start writing QA plus, which is complement of QB, writing as QB is 1. So this becomes 1. And QB next state is complement of QB itself. So itself it is complement. Write it as 1. Again complement, which is 0, and this is also becomes 0, complement of this 0. This again get 1s, and this is also becomes 1, and so on. 0. So what you see, 1 0 1 0 QB complement, it is just only the complement of this. Nothing will change for the frequency. So here your time period is becomes 2t and your frequency becomes just half. It comes out to be 6 megahertz. Your option A. I hope you got a good understanding of this question. This is only based on how you draw your signals and connecting the input with the outputs. You have to only practice on these type of questions. Thank you.